Can we use reality capture to generate images with a masked background and use them in Postshot to create a clean Gaussian splat of our main subject? That is the question we're gonna answer today. I hope you enjoy. So let's first take a look at the dataset that we are going to work with. It's a dataset that I downloaded quite some time ago from the statue of Dante in Verona. It contains about 103 images that have a resolution of 5.4 by 3.6. I will have a link to the original dataset below. So we import these images into reality capture, and we immediately start the alignment process with default settings from reality capture. It goes very quick, about 20 seconds, 21 seconds. And we can see the result here in reality capture. Nice point cloud. All camera positions have been resolved around the statue. And we can do the next step, which for me is scaling the point cloud. By default, the scaling will be kind of estimated based on the sensor size and the camera positions that reality capture has calculated, but I wanted to be more accurate. So I looked up the height of this statue, and what I could find is that it's about 3 meters in height, starting from the base of the statue, so not including the foundations or the foundations that the statue was put on. So I created two control points, one for the top of the statue, and reality capture is very helpful in helping me find the control points in the various images. So this is the top control point, and now we find a good location on the bottom. And then we set this distance to about 3 meters. Constraint distance. You can see that reality capture calculated is 1.6 meters, but we're going to correct it to 3 meters. So it's closer to reality when we reconstruct the Gaussian splat. We realign the images to take into account the new constraint that we have set. After some validation and cleaning, we have our final point cloud. Now the last step is to align it to the ground. The ground floor was not entirely correct with aligning it to the floor. So we make a small correction to the point cloud so that it's based on the floor and it's level as well. So once we have done that, we can export camera positions, and we can also export the point clouds. I'm a bit confused on how to name this for this video. So yeah. So that was the registration, and now the point cloud. And the last step is to save the project so that we can go back if we need to. Once we have done that, we can launch Postshot. We can import the data from reality capture into Postshot. We just drag the images, the point cloud and the camera position into Postshot. And Postshot will recognize the camera positions. It says import them. When we press import, we can see the point cloud from reality capture in Postshot. After doing some validation of the parameters, we start the training process. I did not change anything during the training process or for the training process. And I will speed up this part of the video because it will take about 20 minutes to complete the Gaussian splat with the default settings. Note that this is the MCMC way of rendering the Gaussian splat. We will do a second render later with ADC as the way the splats were generated or calculated. This went very well until this point. And unfortunately, I had to kill Postshot after some time. This is what we see here. And I just restarted the whole process. But before starting the rendering, I disabled all the things in the viewport so that keeping fingers crossed so that Postshot could potentially complete this calculation. And we speed up the video again. And we are almost there. And this time Postshot did complete the 30,000 steps, and we can see the final splat in Postshot. We're not really concerned about the quality of the background. We want to focus on the statue. So here I exported the point cloud that was generated, and we're gonna have a look at it in SuperSplat and maybe do some cleanup in order to see how our statue is looking when we move the background. There are probably some more efficient ways for me to do the cleanup here. But we gradually remove the splats that we don't need in our final reconstruction. So eventually we remove about 2 million splats, and we are left with about 750,000 splats for this statue. Not too bad. Let's save this result so we can use it as a baseline for comparison with other calculations that we will do later on in this video. Once we did this, we're gonna redo the same with another rendering method. Instead of MCMC, we're gonna use ADC. We're gonna compare the two renders. This also takes a while. Same time, about maybe a bit shorter, about 15 to 20 minutes again. And we're not touching the UI, so we can avoid some unnecessary crashes. Postshot completed, and we can have a look at the final result. Looks fairly good as well. Let's export this one, but this time we call it ADC. So before we continue, I'm gonna compare these two calculations. So I'm gonna open up the MCMC one, and I'm also gonna open up ADC Splat and have a look at them in Super Splat. So we can see the difference in how these Gaussians were calculated. The Gaussians for ADC seem to have concentrated around the point cloud. The Gaussians for MCMC method seems to have like more of a sphere layout. We'll have to see what these two rendering methods mean when we are going to use the masks from reality capture to only have the statue rather than the statue and the environment. Now we're back in reality capture, and we're going to create a mask for the images that we want to use for the training process later. To create a mask, we have to isolate the object that we want the mask to be created for. So in this case, this is the statue. So here we set the reconstruction region for reality capture around the statue. Once we have that, we will create a mesh for the statue. And we do this in preview mode. It was very quick. And you can see that Reality Capture was really able to create a nice looking mesh for the statue. Now, to use this statue as a mask, Reality Capture offers a function to export the depth and masks for the mesh. We're gonna put these masks in the same folder as the original image. We don't need the depth information, so we set it to no, but we do export the masks. And then after some time, Reality Capture will start to create masked images for the original images. There they come. And we can have a look at these images, and it's basically a black and white image. White for the parts of an image that we want to be included, and black for part of the image that we want to be excluded. Let's save this project as well. And now we're gonna do basically a new project. We import all the images, including the masks. And Reality Capture will recognize the original images. And it will also recognize that the original images have a mask applied. Now we can do the alignment with the images and the masks together. And this time our point cloud is containing only the statue because we masked out the environment. We're gonna do the same process as we did in the first time that we used Reality Capture. We're gonna set proper scaling for the point cloud. We do a new alignment, and once this is all done, we can export the camera positions again. And we also export the point cloud. And save the project, of course. Now we're back in Postshot, and the first test we're gonna do is to import the original images but use the point cloud that was generated by reality capture with the masks applied, so no environment. Also note that Postshot did only import 103 of the 206 images. We dragged the whole folder into Postshot, containing both the original images and the masks, but only the original images were selected for the reconstruction. It takes again about 20 minutes to complete. And my first impression is that the MCMC method, the result of the calculation is basically the same as the original one. So even though we used a much smaller point cloud to start from, the MCMC method converges the end result very close to when you would use a much larger point cloud. Now let's do the same training again, but with the ADC method. Again, about 20 minutes. And let's have a look at the result in Supersplat. This was the original ADC method with the point cloud including the environment. And this one is ADC method with a point cloud not including the environment and only the statue. And it looked to me that the result was different in that the ADC method now also had more the sphere layout. In the meantime, we are already into the next step. Postshot does not have a function yet to combine a separate mask and an image, so we had to create separate images for this process. So we created an image where we applied a mask and have it as a black background, and we also applied it as a transparent background. We created a small Python script to do that, and to do the conversion it took about 4 minutes. As you may have noticed, the images have now a different name and an extension. The original file name has been extended with mask.png, and we now have to rename the camera locations or the camera names so that it reflects these changes. We use a simple text editor to do that. Now the first test is to create another Gaussian where we use the original point cloud, including the environment, but now with images that have been masked out. First set is the one with the black background, but we soon realized that this process was not going to work. The Gaussian calculation was really trying to recreate the images, and the images of course have a black background, and it resulted in a big black blob. We interrupted the process and we repeated it with ADC applied as the training method to see if it would make a difference. And here you can see that the Gaussian calculation is really trying to replicate the image. But as with the MCMC method, it just results in a big black blob in the whole environment. Now what we wanted to test as well was this black background, and maybe that would resolve the issues that we see, and it would not take the black background into consideration when doing the calculation. And we wanted to see if that impacts the calculation. And at first glance, it does. Like the statue remains kind of clear. But as the training continued, more and more, I would say, unwanted splats were generated. And we also aborted this calculation. One final one was to use the black background as well with the ADC method and see where that gets us. As time progressed, it looked better, so we let the calculation complete. And this was the final result. Massive reduction in number of splats. Let's have a quick look in Supersplat. Yeah, we can clearly see that it has isolated the subject, but there are still a lot of floaters in the whole environment. The results of the training with the black background images were not very satisfactory. So let's now try to do the same, but with a transparent background. The first one is to use MCMC with the transparent background images. And this looks already very promising. Training took about 13 minutes this time. So a little bit faster. And the result was actually not too bad. Let's save this for later so we can compare it with the other results. Let's have a quick look in Supersplat to see the result. Not too bad at all. Still a lot of floaters though. And I think the size was also 1.7 million splats. So it's still a big splat for such a, between quotes, small subject. Let's redo the training with MCMC, but now let's use this checkbox tweet 0 alpha as a mask. And this seems to introduce the same distortions as we saw before. And it seems to introduce the same crash as we saw before. So I guess we're gonna skip this one. And we move on to the next, which is the same as previous one, but now with ADC as a training method. So the original point cloud, images that have a transparent background, ADC as a training method, and no checkboxes checked for now. But after some time training, also this method ended in Postshot not being able to handle what we threw at them. So we skipped that one, and now we will use ADC with the checkbox on and see how that goes. And that one seemed to have made it. Looks good. But a lot of floaters still. Now comes the interesting one, in which we will use the sparse point cloud that was generated with the masked images, and we will combine it with the masked images as well. So the point cloud is from masked images. The images are the images with the black background, the training method MCMC, and no checkboxes checked. I'm still a bit surprised that this point cloud contains so many points outside of the statue. But it's what Reality Capture exported, so we will use it as is, without cleaning. MCMC and black images are not a good match, so we stop the process here. And we will use the checkbox now to see if it improves anything. And it seems to improve something. At least in the beginning. Because if we look halfway, it's already becoming a mess again. Yeah, let's skip this one and move on to the next. And we will continue with MCMC as a training method, but first try the images with the transparent background, combined with the point cloud from the masked images as well. And no checkboxes. And this seems to give a clean result, so let's hope it can finish the training. And indeed it did. So let's save this point cloud and have a quick look in Supersplat. The result of this training method does not seem to be too different from when we trained with a point cloud with the environment. The number of splats are the same, file size is more or less the same, and the result visually looks the same as well. So for MCMC, it doesn't really matter what point cloud was being used to train from. Now let's continue with the same settings, but now with the Treat 0 Alpha as mask, and see what we can get here. And this one completes. And looking at the viewport, it seems that the result is the same again compared to the training from the original point cloud. Now the final ones, we will use ADC as a training method. And this one uses the transparent images. And this one completed and actually looks very good, very good. The size is very small and the result is actually what we would have expected from the first try. Let's use the same dataset, but now again with the Treat 0 Alpha as mask, and see where we get with this one. Visually, it looks a lot like the one with the training method MCMC, so I'm not a big fan. It's not bad, but lots of artifacts. Which brings us to our conclusions. When we started this test, I actually wanted to test two things. First, can we use images with masks to improve the speed of calculating the Gaussian splats? And the second one was to test the impact of the Treat 0 Alpha as mask and the black background in combination with their respective images. And I guess my conclusion is, yes, it makes sense to create masks and to mask out the background, but it has to be the transparent background that we have to use, and we don't have to check the Treat 0 Alpha as mask or black background. I hope you like this test. I hope you find it useful, and if you have any questions, leave a comment below. Goodbye.